Hi guys, this is Neil Davidson here, and welcome to today's Friday Forum. The subject for today is an introduction to masking projector screens. Now, masking projector screens is something that I have a particular expertise in. I'm one of the owners of Display Technologies, and whilst I'm clearly very biased, I believe that Display Technologies makes the very best masking projector screens in the whole world. And I think that there's a good reason for that. The whole company was set up to make the best masking screens in the world. And I think that we were able to achieve what we wanted to do. So for 10 years, we've been immersed in pretty much nothing but masking projector screens. And I think it's important sometimes that we investigate and look back and discuss why we've done that, why masking screens are important, and what the benefits are. And also, we take a look at why we think the DT Dynamic is the very best masking screen on the market. Okay. Now, um, we obviously created DT because we were frustrated at the solutions that we are being offered to us by other screen companies, and there are not so many who do masking screens. So we really set out to do something completely different. So we've really been deep, deep, deep in masking and why it matters and how we optimize that. Now, let's start off by trying to understand what's the purpose of screen masking. So let me share this video. So this is a video. This is on the Display Technologies YouTube, so that anyone can look at it. And this is called the Dynamic 2S. So Dynamic 2S is a two-way side masking screen. So if we just zoom into this, you'll be able to see that. So you can see the side masking there. So first of all, what's the benefit of a projector screen? The black velvet border around the screen plays a very important part in our perception of contrast. It separates the screen area from whatever else is behind the screen, and it really gives us a sense of contrast. So that very nice white screen surface, it's like a visual gap, just in the same way as if you take a black pen and you draw lines around a coloured object in a notebook, it stands out more. It's exactly what happens with a projector screen with black velvet borders. Now, in our modern world, though, we have many, 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 many different aspect ratios. So what that means is that the area of content that's being projected onto the screen, it simply varies. So what that means is that you don't always have content filling the screen, and you get these areas that you can see here to the left and right, or top and bottom, that don't have anything projected onto them. And what that does is it breaks the contrast effect. You have your frame, and then you have an image that doesn't fit into it. You don't get the benefit of the contrast all around. Secondary, you also just have a big white thing next to the screen, which is the unused areas of the projection surface, as you can see there. And what masking allows us to do is it can come in, it can move and hide those unused areas and ensure that we have a nice black velvet frame around the image. Okay. So the technical purpose of a masking screen is to maximize the contrast regardless of the aspect ratio. So that's the primary purpose of a masking screen. Let's face it, it also looks pretty cool when you've got this thing moving. We've been very lucky over the years to be involved with some very large screens. You see, 3, 4 meter tall masks moving. Yeah, that's pretty cool. When you see that type of stuff, let's not underestimate how important that is to people. It's also a sign that this is a high end, a reference theatre, that someone takes image performance as highly as possible. And that's why they've gone ahead and put the masking system in. So we can just see that there as the video continues, the difference that that makes. So that's the general purpose. Let's recap that. It makes your contrast better. It's what we all want, as much contrast as possible. It looks unbelievably cool when everything is moving, or top and bottom, or all four masks are doing their whole thing. And it really marks out the system as a reference level, very special experience compared to more typical systems. And a lot of people value those things very, very highly. Okay, so that's what is the purpose of a masking screen, and why we would use a masking screen. Now, does anyone have any questions on those before we move on? Nope, everyone's happy. Okay, perfect. So that's obviously just a pretty quick intro. I think you guys can understand. I think everyone in this particular room has seen a masking screen before. So let's look at how a masking screen can get integrated into our project. And let's look at why we felt that we needed to do something different. Now, um, by definition, a masking screen is pretty large. Okay. We sort of joke about it and we go, oh, it's only a 4 meter screen. 4 meters is absolutely huge when you see it on a wall. A 4 meter screen could weigh 200, maybe even 250 kilograms. It takes up a lot of space in the room. You're moving these big things. How are you moving them around? You've got motors, you've got electronics. How does it all link together? How does it all function? Is it noisy? Is it difficult to do? Are you going to need a PhD in electronics to put the whole thing together? Well, what we wanted to do with the dynamic was come up with a way of solving all of these problems, basically, and make a masking screen that was as easy as possible to install, to integrate with the control system, and to commission and use. All of things that we thought were completely lacking in other systems. Okay. So let's start off with install. This isn't the order that we developed it in, incidentally, but install makes the most sense when we talk about these things. So a dynamic masking screen uses a system that we call install on the wall. And on the surface, it doesn't seem that complicated because, it's a projector screen and it's going to go on the wall somehow. Now, if you look at everyone else's projector screen, this thing that I've said might weigh 200, 250 kilos plus, 4 meters wide, 5 meters wide, gigantic things. What you typically have to do with them is lay them out on a clear surface in front of the wall that you're going to install it on. Assemble all of the parts together and then lift that up onto the wall. We used to see it all the time. There would be a moment that you just needed, 8 people on the site to lift this screen into place, and it always just struck us as crazy. So when you get a dynamic screen installs in sections, and those sections are mounted directly to the wall, one piece at a time. So let's look at the Dynamic 2S again. So the section that you're looking at on the screen right now, that is a bottom left-hand section. It has these mounting holes, and if you can see the mounting holes, there's a slotted hole, there's a countersunk hole, and there's a flat hole. So we've tried to account for all different mounting types. Slotted gives you a little bit of adjustment there. So the first step is to level that off, put your screws in, and fix that piece down. Okay, that's going to set the level of the screen. Next comes our bottom right section. So this is a Mask 2S. That already has the controller integrated inside of it. Okay, that's not just a trick of the render. It's already integrated inside it. It bolts onto the section that you already put in. There are slide brackets that slide between the two and lock down, and then you have those extra screw fittings to secure it. Next, you put the left-hand side on. The left-hand side comes with the mask already integrated inside it. The item that you see down here, that's a sensor control module, already integrated inside it. The actual sensor itself is integrated. So everything is already on that section. Slide it together, tighten up the lock nuts, and away again. You see the sensor, screw goes in the middle to set it. Then we put the top sections in. Now, the screens do come with spreader bars, and those spreader bars, they're basically there to help you at this second tier, where you're putting the top sections on. So spreader bar goes between the bottom and up to the top, to take the weight, basically, of that section until you can fix it in. So there you see it, next spreader bar. The lock nuts go together. That's your cable entry, and there you have it. So the screen installed in sections straight onto the wall. You've never had to have a minute where you've lifted the whole weight of that screen. You're not going to have to add lots of electronics or anything like that at the end of it, because it's all integrated into the frame itself. Um, that's a sensor module which is connected to the mask bar. We'll cover that a little bit later. There's a little control module which controls the motor. There's a plug that comes out of the controller. It's all pre-wired. So you put the plugs into the controller and you put the plugs into this control box here. And that completes all of the electrical connections inside the screen. And all you need to do is add power and whatever your chosen control protocol is, Ethernet or RS-232. And that completes the connection of the screen. Now, anyone who's ever done a masking screen knows that getting it onto the wall is only the start of the challenge of integrating that screen. Now, what I want to point out is, of course, there are no covers on the screen at this minute in time. Our black velvet covers install from the front once the screen is installed. There's no fabric installed in the screen. There's no image surface at this minute in time either. You can put this frame up well in advance of installing the image surface because it also installs from the front. But what you can do, as soon as you apply power, and there are actually tension bands in here, which I should have mentioned also, and connect the tension bands to connect the masks together. The control unit has um, a little keypad on it, and that keypad allows you to test the operation of the masking. And you can do that because the screen leaves the DT factory fully programmed. It knows what size it is, it knows what masks it has, therefore it can compute what size or what position basically the masks should be moved to create a given aspect ratio on the screen. So as soon as you plug that in, one of your techs on site can just go boop, 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 check everything is okay, done. Doesn't need to be integrated with control system or anything at that point in time. Now, this is the peripheral. So the peripheral is what controls the masks. Now that purple cable, that's actually a CAN bus network cable that communicates with the main controller. So inside a dynamic screen, you actually have a microcontroller dedicated to every mask, plus a main microcontroller to coordinate everything together. And I don't know if you can see there are open and close buttons on there. So again, the reason that there are open and close buttons is if for any reason we need to test that if a mask is working correctly, we can bypass the whole system and just go straight to testing. Does it move? So again, that's an important feature for us in the factory, but also when it comes if there's any debugging or troubleshooting needed on the site, that happens as well. Okay, so there we go. We've put the image surface in, and then the black velvet covers go on. So that completes everything. Okay. So that's the build on the wall system that we use in DT Dynamic. It's completely different to what anyone else was doing before that. Very flattering now that some people have taken inspiration, but that was a unique development from Display Technologies and really designed so that you never had to have the full weight of the screen at any one time. Now, um, of course, just occasionally we do see people who are doing a gigantic four-way masking screen that has a huge roller. Okay, still a heavy part, but still much less heavy than trying to lift up the whole screen with all of the rollers and all of that type of stuff. So that is the sort of the build process that we go through for the screen. Now, does anyone have any questions on the build process? No. Okay. So then let's just take a little look at some of the tech that we've built into these things. So here is a better view of what we were just talking about a second ago. Um, This is the front loading system. So again, all display technologies screens have got a front loading image surface. What that means is that you install the frame onto the wall, then you install the image surface. These two sections here are because we're looking at a 2S. These are little internal cover plates which hide the top and bottom of the image surface and make it look like the mask bars of the masking screen when they move. And then finally, we have the magnetic front cover that goes over everything. Again, that's common on every DT screen. And the Frontier fixed frame screens and everything all work that way. Now, this year we did a pretty major upgrade to the front loading image surface. What we also did is it's now tool free front loading image surface. So what that means is that you do not need any tuck tools or anything like that to install the image surface in a DT screen. All the image surfaces come with a thing called a silicon edge. It's like a rubber band for all the world around the edge of the screen. And that's stitched on to the screen in our factory. And it just simply pushes into a groove on the screen. So that means, one, it's very much easier to install, but two, it also means that you can remove the screen. I always thought it was bizarre, but it's also the thing that people ask about the most. How easy is the image surface to remove? Very easy. And then you can reinstall it. It's not like a one and done type thing. It's actually the same system that's used within our fabric walls products, so that you can also do cinema fabric room treatments that you can remove and install tool free. So uh, a really, really important development. So tool free front loading image surfaces. The second thing is these silent glide linear bearings. So all of our masks run on a self-lubricating um, plastic bearing. What that means is that they're extremely quiet, but they're also well guided. It's not just like loose or on a wheel or something like that. They really run on a bearing that keeps everything nice and tidy. I already mentioned our control interfaces. So the screen comes with RS-232 and Ethernet as standard. The control module is built directly into the screen frame. There is no external control module that you need to add to make the screen work. It also has IR. Now, I'll just say that IR is not meant to be for normal usage. Um, we don't expect someone to sit with one of our infrared remote controls that I have here. And the reason for that is that um, we're not able to do mask position logic, which is our biggest technology, via IR. The IR is there to help you during setup. It's before you might have got a control system connected or anything like that. You want to test the masks or maybe align a projector. The IR is there to help you. And what the IR does is it matches the features that are on the little keypad, which is built right onto the front of the control box. So that literally when you plug it in, there's a button there and you can do what you need to do to control the masks. So pretty unique features. We have our Whisper Tech system. Now, um, WhisperTech is a combination of how we do tensioning. So we use a band to do tensioning, and we use the band because it's so quiet. Um, Everyone laughs. Yes, it's like a big rubber band that goes between the masks, and that applies the tension onto them. We found it a very reliable system over the years, and we're very, very happy with it because it's absolutely silent in its operation. That allowed us to get the best out of our motors. So believe it or not, we do have custom motors made for us as well. The reason that we have that done is that we need a special gearbox to supply the level of power that we need, whilst also having the very, very low noise levels that we look for in the systems. So all of those things together um, really illustrate the sort of technology that goes into the system. Okay. So silent bearings, silent bands, special motors to keep it all as quiet as possible. Easy integration with the control unit, with IP and RS-232. So everything that you would need to have a very straightforward experience. Um, does anyone have any questions on those little items before we dive into mask position logic? Nope. So, um, all of that's all cool, but anyone can do that sort of stuff. The real thing that sets a dynamic screen apart from any other screen on the marketplace is a technology that we call mask position logic. So mask position logic is really a proprietary development of display technologies. And how do I know it's a proprietary development? Because I did it, and I have all the code right here. So all of the electronics done in-house, all of the software done in-house, everything done in-house to allow us to deliver this technology mask position logic. So what is it? Why am I bragging about it? Well, if we go back in time again to the start of display technologies, it used to drive me crazy that masking was driven by a preset. It was effectively two blinds moving towards each other, okay? And it wasn't treated any different. Now, if you're lucky, a preset driven masking system might have 6 presets, 12 presets if you go crazy, double memory. Well, in this day and age, that might not be enough to support all of the crazy aspect ratios that are available, especially not if you have a client that is interested in subtitles, for example, or they want to do some particular framing. Um, Quite often, if you're involved in production and stuff like that, they are interested in how what framing can we do here? A little bit custom stuff. Now, the downside of a preset driven system, even if you have infinite presets, is you have to set the presets. So what that means is that when you build the screen, your job is only half done. You've still somehow got to go around each individual mask, move it into place, save that, write down somewhere what aspect you put into that preset, and then know how to use that later on to try and make the system automated. You can easily spend a day doing that with other people's systems. There's one very particular system that uses IR to move the motors to save them to set the presets. And the remote control has like 3 buttons on it. I have very vivid memories of hanging out of the cinema to try and point the IR at the separate, non-integrated control box that was included to try and do that. Was a very painful experience, and it took forever, and we never got it quite right. There was always one mask that just was a little bit off center and super annoying for a guy like me. What we do with mask position logic is completely different. In the factory, we program the width and height of the screen into the controller. It actually detects then what masks are connected to it. And because of that, it can do some bit of maths that if you tell the screen that you want a 1.78 aspect, it knows exactly how far the masks have to move to produce a 1.78 aspect window on the screen. So we call that aspect-driven masking. We don't need to use presets on a DT dynamic. If you want to go to 1778, that's actually a distinct thing from 178 or 1824 or any of these types of aspect ratios. And if you're doing big screens, 6 meters or whatever else, it's hilarious. 1778 is a few millimeters different than 178, and they actually do move the masks between those two positions. So what that means is that out of the box, as long as the masks can physically move to that position, every single aspect ratio is supported. There's no presets to set up. You just plug it in and it's ready to go. Now, um, that also completely changes the experience when you come to integrate with other things because you don't need to think to myself, now what did I save in preset one? Was it 185 or was it 178? Hmm. Yeah, just say aspect 178 or aspect 235 or aspect, 2020. Whatever you want, sir, you can have it, no problem. And that's mask position logic. That's what makes a dynamic screen so different is our custom software and electronics platform. Now, let me just show you a close-up of a couple of the little key parts of a mask position logic system. So here's a zoomed in view of a DT dynamic controller. You have power just on an IC cable. There's a 12-volt trigger there that's not used. You have RS-232, and on the other side there you have an e-stop. You have a CAN bus connection. You have IP, and you have USB. On top of that, you have all of these control buttons. And if I actually do that, you can see those other ports. Oh no, that was the wrong one. Sorry, apologies. So then you have these little control buttons that you can press. The gear icon is install. Install allows you to move the masks outside the area where our front loading fabric is going to be installed so that you can put the fabric in. Home is like the native size of the screen. So that would be if you ordered a 2.37 screen, that would put the screen in 2.37. We have 1.78 and 2.35 as typical aspects to move between. And then we have these art up and down. So we still do make art mask screens for people where an art cover panel drops down to cover the whole screen. But much more often these days, it's actually just a black panel If people want to be able to fully protect the screen when it's not in use, that's what those two buttons allow to be controlled. So really everything is integrated into this little box, which is integrated into the screen. And what that box does is that takes the information that you as the user provide to it via the buttons or by RS-232 or by IP, or all of them if you want to, because it doesn't care. Um, and it uses that to calculate where the mask should move to. Now, once it's done its calculation, it sends that data over the CAN bus to the peripheral. So we already mentioned the peripheral. This is the little box that controls the motor. All that the peripheral is doing is being told, you move, let's say you move 722 millimeters towards the middle of the screen. That's all it's going to do. It's going to control the motor to make sure that that happens. But what it also does is it communicates with this little unit up here. So this is our measuring sensor. So yes, every single mask on a dynamic screen is connected to a sensor. What happens when the mask moves is that that wire extends. I'll show you here. So it tracks constantly where the mask is. It's not like an encoder or anything like that. It's literally connected to the mask, and it will always detect. So why is that important? Because we did try encoders because it was a lot easier than having all of these sensors. What it does is it corrects for any stretch that you might have, for example, in the masking fabric. It corrects if, you know, after 3-4 years, you might be getting towards the end of the life of the tension bands. It corrects for changes in humidity and temperature and all of those types of things. It can just affect, how far stuff is moving, if they're a little bit sticky or anything like that. It really measures very, very, very precisely. So how precisely? Well, our peripheral does a 14-bit measurement sampling of the output from the sensor. So we have a 14-bit analog to digital converter built into every one of our masking controllers. So that gives us sub-millimeter accuracy, basically, on the measurements of these things. Now, I'm sure you can also guess that these fancy sensors are calibrated, but they all have slight variances. So what we also do in the peripheral is we do an 11-point calibration of every sensor so that we have absolute accuracy right across its whole operating range. Very, very, very precise system that works in there. So mask moves, sensor measures, data goes to the peripheral, which controls the motor, and then it also tells the main controller when it's in position or not. And that's how we get the accuracy with inside the screen for a mask position logic system. Now, that's not a small thing to do, all of that processing, but that's how we get the level of performance that we want to have. Now, I just wanted to end Sadly, of course, I'm in my office whilst we're recording this video, so I don't have a 6 meter screen on the wall. But let me just show you something here. Share my screen one last time. So this piece of software that you see on the screen is called Dynamic Commander. So Dynamic Commander, I apologize, is PC only, is Windows only. But this piece of software allows people to plug in via USB and really monitor every aspect of the screen. What happens once it's connected is it shows you on this chart here the position of all of the masks, target aspect, current aspect. It's all plotted in time up here. It lets you easily control the screen, install, home, closed. You can put in a custom aspect here, make it go to a custom aspect. Now, although I've teased presets, you know what, there are still valid reasons to use presets. A dynamic screen has something like 50 of them inside it, you know, just because we have plenty of presets. Now, what we also do with this is we have a little bit of control over the settings of the masks. So install is a millimeter position, home and closed. So that controls basically where the mask is going to be able to move to. Then we have some information. Is the mask installed? What position is the mask at? What speed is it moving at? Is it moving? Does it have a fault? Okay. And then we can also directly control that mask. That's the little peripheral. That lets us directly control if we want to make that mask move to, 225 millimeters. If I do that, if I was connected to the screen, the mask would now move 225 millimeters. Okay. And then in the factory here we see this is where the size is set. So that's how that's all programmed into the screen. So Dynamic Commander is a really important part of doing a setup. You don't normally need to use it, but it helps often if you're really looking to do fine tuning, complex things, presets. Just make sure the masks are doing exactly what you want them to do, etc. So that's our software there. So hopefully you've seen that masking screen is there to help contrast for all aspect ratios, but also to look amazingly cool. I hope that you have seen that the dynamic from DT is the easiest to install because of the on-the-wall install technology. The fabric is very easy because it's tool-free, front-loading fabrics. Then we have the power of mask position logic that lets us control everything. So very, very easy to integrate into a system. Now, um, does anyone have any questions about those points, or is everyone pretty happy with that so far? Oh, everyone's pretty happy. Good. Now let me just show you one last thing quickly to do with integration. Uh, So what you see on the screen here is a little terminal software called Hercules that's quite popular. And Hercules is fantastic because it lets you do TCP as well as RS-232. Now, if we wanted to connect with a DT screen, actually any DT product, over IP. You put in the IP address and the default port is 20108. We would connect to that. Now, every DT product has this command built into it, which is help. So exclamation mark help and then a carriage return will get you the list of supported commands. If we want to make the screen move 1778, that's my command, aspect 1778. That's my command to make the screen move to a 1.778 aspect ratio. So really, really a very, very simple control protocol. And that control protocol, we don't make drivers for Control 4 or anything like that. You can just use a generic IP driver to send these dead simple strings to the system. It doesn't need anything fancy. Just stop the share. And what's cool is companies like MadVR, so MadVR who make the Envy line of video processors, which are very powerful aspect ratio detection built into them. And the guys at MadVR recently added a thing called device control. Device control will take the aspect ratio and then send that exact aspect data to a dynamic screen. You don't need to do anything else. There's no presets to set or anything like that. Just enable it, and then it all magically works. Very, very, very powerful system, which is enabled by mask position logic and all the rest of the stuff. So that's really the essence of DT masking. I hope you've enjoyed the discussion. If anyone's got any questions, then I'll be happy to take them. But that's us for this particular session today.